All right, everyone. Today is about volume of prisms and cylinders. And if you remember, volume is basically the amount of three-dimensional space an object occupies. And prisms and cylinders are very convenient because, in general, all prisms and cylinders have this generic volume formula here, which you can see is capital B times H. And what that means, capital B in this case, means the area of the base. So if you know the area of the base shape of a prism, whatever that base shape is, or a cylinder, which its base is a circle, you can find the volume of these figures. So you can see here capital B, they're trying to represent that as the shaded area of the base, times whatever the height is. So let's take a look here. Let's get a little bit more specific. If you're looking at a rectangular prism, if you remember, the area of a rectangle is base times height, or length times width. So this is probably the most common volume formula that people remember. The area of the base is length times width, and then you'd write times height. So length times width times height, you may have heard that before. That's for rectangular prisms. For a triangle, the area of a triangle, that would be the base shape here, is 1/2 base times height. Now you'll notice I'm writing these as lowercase because in a triangle, like if you had a triangular prism, let's say, this is my very bad drawing of one. Whoop, whoop. The base and height of the triangle are these guys. So if it'll usually be a right triangle, just so you guys know, this would be its base and this would be its height. So that's why we use little b and little h. However, there's also a height of the entire prism. That's this amount right here, capital H. So we'll see that more in an example to come, but basically these are different things. Lowercase h and uppercase h. Little h stands for height of the triangle, big H stands for height of the prism. Okay, and lastly, volume of a cylinder. If you remember the area of a circle, it is pi r squared. And then we would just write times h. So let's put these into action, shall we? So here's our first example, this triangular prism. Now this is sort of what I was just saying to you. If it's a right triangle, which it will always be a right triangle, in any right triangle, remember how you guys learned a squared plus b squared equals c squared? Well, a and b, everyone, are always going to be the base and height. So, in other words, if you were to look at this triangle and maybe draw it this way, and here's 8 and here's 10, you would say 8 is the little b and 10 is the little h. All right? So, basically, it really doesn't matter because you're just multiplying them anyways. But the main thing I want you to take away from this is that when you see a right triangle, you don't use the hypotenuse. That's another way to think about that. You don't use the hypotenuse, you use the other two. So that's little b, that's little h. And then a big capital H has to be the 10. And now it's the 10 on the right here because it's the height of the entire prism. It's the height from triangle to triangle. And again, if you're a little confused on that, as long as you know don't use the hypotenuse and you're just multiplying, it really doesn't matter. Because if your formula is to multiply 1/2 times little b times little h times big H, you're just going to multiply these numbers together anyways. So the actual answer for this question is the following. You would have 1/2 times 8 times 10 times 10, and that comes out to 400. Now, they didn't give you any units. It doesn't say centimeters or feet or anything like that, but when you calculate volume, everything is cubic units, or raised to the third power. So you're going to see that happen throughout these notes. And if you're curious what this blank is here, they wanted you to use the triangular prism formula. Okay. So we're going to move on to example 2. Give yourself a moment to write down what you see here. Pause the video if you have to. And let's take a look at number 2. So number 2, this is a rectangular prism. And in a rectangular prism, you're looking for a length and a width and a height. But again, if you're not so sure how to label things, Usually we say length is this one right here. Width is like the depth, if you will, how far back it goes. And then height is how tall it is. But again, when you use a rectangular prism formula, length times width times height, it really doesn't matter how you label them. You're just multiplying these numbers. All right? So if the work for this is to multiply length, which is 24 centimeters, times width, which is 20 centimeters, and height, which is 10 centimeters, you're just multiplying. It doesn't matter what order you write those numbers in. So if you multiply, you're going to get the number 4,800. And if you know anything about properties of units or exponents, centimeter times centimeter times centimeter is centimeter to the third power. That's why it's cubic units when you do volume. All right, so rectangular prism, probably the easiest one. Triangular prism could get more challenging if it's a tougher triangle to understand, but most of these will be pretty straightforward. Now what you see here is what's called oblique. Oblique means slanted. So this is a shape that is on a slant. But still, even though it's on a slant, it's the same formula. So what I mean by that, you still are finding the area of this base right here. So the area of a parallelogram is the same as a rectangle, it's just base times height. So you're still doing base times height, or length times width. And then the height, even if something's slanted, its actual height is its distance from top to bottom in a perpendicular manner. So this is still height, this is still L, this is still W, and you would still just multiply them. So again, even if something's on a slant, like if you had a stack of books and you pushed the top a little bit and now the stack looks like this, how tall it is still right here. You wouldn't measure it on the slant. All right, so that's what's going on here. Occasionally you'll see a problem like that, but again, the work is very straightforward. You're going to have 8 times 5 times 19, and that's going to give you an answer of 760. And again, if there's no units, if it doesn't say centimeters, feet, whatever, just write u cubed or units cubed. You always want to write that at the end. All right, we're going to move on to cylinder. Cylinder has a circle base. So if you remember, for a cylinder, the formula was pi r squared times the height of the entire cylinder. Okay, and here we go. In this problem, the radius is 3 and the height is 8. So it says to leave our answer in terms of pi. Cool, we've done that before. So here we go. We have pi times the radius, which is 3 centimeters, squared, times the height, which is 8 centimeters. All right, and because we're leaving our answer in terms of pi, we're really just going to work with the numbers. So 3 squared, that's 9. And since it's centimeters squared, we have centimeters squared, times 8 centimeters is going to give you 72 centimeters cubed. But you can't forget about pi, and that's really what they mean. In terms of pi, just means do the numbers and then throw pi in here. So the volume here is 72 pi centimeters cubed. All right, and our very last one. We have a little grain silo here. Now technically you have a hemisphere or a half a sphere on top, but we're not getting into that because we haven't even talked about volume of a sphere yet. So for this problem, we're really just talking about the cylindrical part. How much grain can you fill in there? And let's say they're leaving the top open. So we're looking for how much you can fill in there. So it says what a silo is, cool. And then it says which holds more. So let's call this silo 1 and silo 2. All right, silo 1, it says has a height of 50 feet tall is like saying the height is 50. And a silo is shaped like a cylinder. So if it says it has a diameter of 10 feet, remember that means you have a radius of 5 feet. That's really what we want. And number 2 It's 35 feet tall with a diameter of 12, so that means it has a radius of 6. So we're basically going to find the volume of these two and see which one holds more. So starting with silo 1, volume is going to be pi times radius squared, 5 feet squared, times height. And number 2 is going to be same formula, just different numbers. Pi times 6 feet squared times 35 feet. And if you just work with the numbers, 5 squared is 25 times 50. This is going to be 1250 pi feet cubed. And you don't have to multiply by pi because you can still compare the coefficients, the numbers in front. And over here, this one, guys, 6 squared is 36 times 35 is actually going to give you 1,260 pi feet cubed. So again, you don't even need to multiply by pi. Which one has a bigger number in front? This guy. So silo 2 can hold more grain. It doesn't say how much more. If it did, you would subtract the 2, so you would really just say it's silo 2 in this case. All right, the homework is pretty straightforward. It's pretty basic examples similar to what you saw here. Again, if you need to pause anything, write down anything, ask any questions, please.